Okay, once this YouTube stream starts, we will actually start with the CMake tutorial, step 4, and actually start with... Okay, now we're starting. This is step 4 of this official CMake tutorial that we're going through. In the first one, we got introduced to how to set up everything. Step 1 was how to link everything together, like to build a single CPP file, to link it with a header file, to actually build and use a static library. Step 2 introduced us to that CMake works only with strings. Everything is a string, and we got introduced to what a macro function and lists are, and some functions with lists. We even implemented some of them. On step 3, configuration and cache variables, here we saw how we can set flags and cache variables, where we conditionally, based on a flag, decided if we will compile a library or not, and to set which C++ version we're using. We set it to use version 20, so we could have access to std format. And we got introduced to CMake presets JSON, where you can set there all of those options, so you don't have to set them every time. CMake presets JSON, amazing file. It really helps. Extremely useful file. So far, I'm really liking these CMake tutorials. Like, I don't know how I have existed without them. And we're on step 4. Okay. We are on step 4. Everything is ready. Here we are in step 3. We'll move back. The tutorial has all of these 4 folders that we download, and inside them we have exercises. And we'll go into the step 4 folder for today's exercise. Let's see what step 4 is about. I haven't read it. In-depth CMake target commands. There are several target commands within CMake we can use to describe requirements. As a reminder, a target command is one which modifies the properties of the target it's applied to. These properties describe requirements needed to build the software, such as sources, compile flags, and output names, or properties necessary to consume the target, such as header, includes library directories and linkage rules. Note, as discussed in step 1, properties required to build a target should be described with the private scope keyword. Those required to consume the target with interface and properties needed for both are described with public. In this step, we will go over all the available target commands in CMake. Not all target commands are created equal. We have already discussed the 2 most important target commands, target sources and target link libraries. So target sources is when we so here we have add executable. This is our target. This is the exe file we'll be running, and it's called tutorial. And these target sources, with this command, we give the CPP files, header files to the executable. That's how we give it to them. And target link libraries is how we link the static library. Here, math functions project is a static library that we built, and with target link libraries, that's how we link our tutorial executable with the math functions library. Yeah, we've already covered those target sources and target link libraries. Of the remaining commands, some are almost as common as these 2. Others have more advanced applications, and a couple should only be used as a last resort when other options are not available. Before going any further, let's name all of the CMake target commands. We'll split these into 3 groups: the recommended and generally useful commands, the advanced and cautionary commands, and the food gun commands, which should be avoided unless necessary. Okay, common recommended. Target sources, target link libraries, those we know. Target compile features, target compile definitions. Advanced caution. Get target properties, set target properties, target compile options, target link options, and target precompile headers. Oh, this one. I'm using this one. In the engine that I'm trying to build with CMake, I'm trying to add precompiled headers, and right now I'm failing at doing it. So it's advanced caution. And esoteric food guns target include directories. Include directories? Seriously, that's a food gun. Yo, I'm surprised because I'm using it. I'm surprised because I see other CMake files use it as well. So interesting that it's a food gun. Target include directories, target link directories. Interesting. There is no such thing as a bad CMake target command. They all have valid use case. It's a target command. Yeah, it's a target command. They all have valid use cases. This categorization is provided to give newcomers a simple intuition about which commands they should consider first when tackling a problem. So when we want to have directories, like include directories, I should first go from common recommended, then to advanced, and then try to actually use this. And I'm interested to see how I could have include directories with one of these options. I don't feel like it's possible. We'll demonstrate most of these in the following exercises. The 3 we won't be using are get target property, set target properties, and target precompile headers. This is the one I want to learn about. So we will briefly discuss their purpose here. The get target property and set target properties commands give direct access to a target's properties by name. They can even be used to attach arbitrary property names to a target. So we have a library and we set target properties key value hello world. Set target properties. And here get target property key var example key. Get target property hello var example hello. Message key var hello var. So here we are declaring variables. Example is the target. This is the target. And key is this. And hello is this. And this is the value that is stored in the property. Okay, and these are custom properties we've declared with set target properties. Here we are getting them. Can we set them as well? If we change the key var variable, or is there a set target property? Yes. No. There isn't a function like that. The full list of target properties which are semantically meaningful to CMake are documented at CMake properties. Okay, what are the properties? Properties of global scope. Source files. Man, there are many properties. Shader fax. What? Include directories. Yo, so maybe instead of using target include directories, we'll be setting properties where there is a property like include directories. And maybe it will be a list of like the directories. Interesting. Maybe that's what they meant. We'll demonstrate most of these in the following exercises. The three we won't be using are get target. We read that. Yeah, the full list of target properties. Let me move this. Okay. However, yeah, the full list, yeah, it's from here. However, most of these should be modified with their dedicated commands. For example, it is unnecessary to directly manipulate link libraries and interface link libraries as these are handled by target link libraries. Uh, target link libraries, it's here. Conversely, some lesser used properties are only accessible via these commands. The deprecation property used to attach deprecation notices to targets can only be set via set target properties, as can the additional clean files for describing additional files to be removed by CMake's clean target, and other properties of this sort. Also, when we use the clean target when compiling, we can set it to remove additional files. Interesting. The target precompile headers command takes a list of header files similar to target sources and creates a precompiled header from them. This precompiled header is then force included into all translation units in the target. This can be useful for build performance. Yeah, that's exactly why my reason of using it. Okay, straight to exercises, features and definitions. In earlier steps, we caution against globally setting CMake lang standard and overriding packagers' decision concerning which language standard to use. On the other hand, many libraries have a minimum required feature set they need in order to build, and for this it is appropriate to use the target compile features command to communicate those requirements. Target compile features. Yeah, here. My app, private, and the standard. The target compile features command describes a minimum language standard as a target property. If the CMake lang standard is above this version, or the compiler default already provides this language standard, no action is taken. If additional flags are necessary to enable the standard, these will be added by CMake. Target compile features manipulates the same style of interface and non-interface properties as other target commands. This means it is possible to inherit a language standard requirement specified with interface or public scope keywords. If language features are used only in implementation files, then the respective compile feature should be private. If the target's headers use the features, then public or interface should be used. Yeah, I was wondering why here we can state private, public, interface, etc. For C++, the compile features are of the form cxx, std, and here the standardization year. Here I should put 23 for my personal project. The target compile definitions. A command describes compile definitions as target properties. It is the most common mechanism for communicating build configuration information to the source code itself. As with all properties, the scope keywords apply as we have discussed. It is neither required nor desired. that we attach the prefixes to the compile definitions described with target compile definitions. CMake will determine the correct flag for the current compiler. So in this exercise, we'll be using both of these. Okay, target compile features and definitions. With features, we can set which version of C++ we're using. With definitions, it's used for communicating build configuration information. So for the build, as with also when it's building, to set like flags. Okay, we have to use both of these in the exercise. In step 4, to do 1 through 8. Yeah, we are in step 4. Here to do 14, to do 4. Here is to do 1. Now, the minimum version of CMake to use. This is the project. Now, this is a flag. Tutorial build utilities. Yeah, this is if we will build the executable or not. And by default, we are building the executable. And then we have here the static library we are creating. And here we have vendor. What's vendor? Yo, an include folder and a lib folder. And oh, it's another library. It's another. Man, this exercise is getting more interesting. Because it's interesting because if we manage, well, if I manage to learn all of these, we will move on to possibly being able to compile my engine with CMake. Okay, we add the subdirectory vendor here. Add default of option named, okay. Option name tutorial use std square root. And here will be the description. And by default, it's off. Okay, we added the option. It's our own custom made option. By default, it's off. I suppose next we have to move here. Because we just added the option that has something to do with this library. Add a compile feature for C++ support to math functions. Add a conditional which checks tutorial uses and if on, set a compile definition on math functions of the same name. I think they're asking for this. Target compile feature for math functions. And yeah, we are setting it to 20, C++ 20. Add a condition now. So an if which checks this flag, and if on, set a compile definition on math functions of the same name. A compile definition. Yeah, compile definitions. Okay, we're setting. Let's just set it as private. And here will be the name of the static library. Isn't it a problem that it's the same name? It's a compile definition. And here it was like a flag. Okay, that was to do 3. Now to do 4. Other compile feature or C++20 support. Here we're to the target. So to tutorial, because that's our executable. To do 4, where is to do 5? To do. Yeah, here is to do 5. So this is a simple to do, straightforward. To do 6. And here is the square root function. Check if tutorial use square root is defined. If is defined. Oh, but here we're working with C++. It's not the CMake. Oh, compile definition. I get it now. So the flag we used here in this if is the CMake one. And here, this definition is for C++ inside of the code itself. Yo, cool. Check if is defined. If so, use std square root. Wasn't it like if defined? C++ check if defined. Like if defined. Is it if defined? Like if defined. Like that. And if. Is it like that? If defined and if else. Else. Okay, check if this is defined. If so, use std square root instead of my. So here it should be std square root. I get it now. This to do 6. We are looking for to do 7. Five, 6. Oh, is it inside of these ones? No. 11, 12, 13. Oh, the presets. Yeah, to do 7. Remove the standard. And this to do. Yeah, we have to remove it because now we are setting it properly. To do 8, set tutorial use std square root to on. Yeah, that's the option where by default we've set it to false. This was to do 8. We need to do 9. Yeah, here is to do 9. Add the compile flag to tutorial. Wait, what's happening? Here we create the executable, we give it the CPP file to the executable, we link it with the static library, we set the C++ version to 20. If this string is equal to this, or is that. So this is if we are using Visual Studio. This is if we're using Visual Studio. Else, if GNU or CLang. So this would be our case. Add the wall compile flag. So we are adding a compile flag. Okay, they say what to use. They said helpful resources. Option. Yeah, I think it's option. Or we can use set like cache string, but we can do it option. This flag. But options was differently set. It was like without. Like this, and it had a description. This is like predefined one. If we are setting, we should use set like that. Yeah, we should use like set, but set. And here to on cache string like this. I'll do it like that. We'll see if there is an issue. And here it should be wall compile flag. Oh, but this is added to tutorial. And here we are not specifying tutorial, so it should be. No, it's compile definitions, compile features. Okay, here they're talking about compile flags. Let's search flag, compile flag. This is the only part it's mentioned. Compile flag. For compile flags, what I've learned from previous steps is to use either set or option. Compile flag. This is still step 4. Let's go to the previous step and search compile flag. Okay, flag. Yeah, these D flags. Like we could give them like this, but here we're looking for to set them inside of CMake. Okay, we'll leave it as set, and the solution will tell us if we are wrong. To do 10, we've done it. To do 10, so to do 11. To do 11, where is it? Here. Add the include directory to vendor lib. Add the lib directory to vendor lib. Oh, so this is in vendor lib. We have a library, vendor lib, and target compile definitions. Compile definitions. Yeah, we're setting tutorial use vendor lib. So this would be used in code. But here it's not used. Add the include directory to vendor lib. Add the lib directory to vendor lib. Add the vendor archive to vendor lib. Let's target compile features, definitions, option, and if include directory to vendor lib. So how would we add a directory to vendor lib to our static library? Like what comes to mind at first is to use target include directories. By doing that, we'll have the include directory and we'll have the lib directory. The other way we could do it is with set properties, but I doubt it. That's what they want. Okay, let's do it this way. Target include directories vendor lib, and we want include folder. And here we want lib folder. Add the vendor archive to vendor lib. What do they mean by vendor archive? Archive. I don't see anywhere mention of any archive. Only here. There is the only place they mention an archive. Building an archive. Here it's a project. But this is exercise 3. Oh, yeah. That's why. Yeah. Oh my God, we went too far. They wanted only 1 through 8. They wanted 1 through 8. This is 11. We have to remove them. 11, 10, 9. Yeah, 1 through 8 are done. Yeah, let's look at the solutions. Preset tutorial and compile. CMake preset tutorial. Okay, build. We build it and verify that the output of tutorial is what we would expect of square root. So build and then tutorial and then the executable. Yeah, but we need this so to be able to get then 4. Yeah, the square root of 4 is 2 and we are using in the library here we're using this square root actually. Here NeoVim is not recognizing it. We can actually try to make it recognize it. Def CMake step 3 presets and export compile commands. And now let's CMake preset tutorial, build it, and now let's see if it recognizes it. Yeah, now it recognizes it. Here we can see that this worked. Tutorial. This is configured through here. Because we have this flag on, it uses this target compile definition. We have set this target compile definition. Okay, we set these options and target compile features. Yeah, we set the version to 20. And if we have this flag, we set the target compile definitions. And then we set the for tutorial project to be version 20. Now we can modify math functions. We set this new include and we set this if defined. Else to use this square root. Finally, we can update. Yeah, when we updated the CMake presets to actually set this flag as on. Because by default it's false. Here, by default is false. Compile and link options. This is the second exercise. Sometimes we need to exercise specific control over the exact options being passed on the compile and link line. These situations are addressed by target compile options and target link options. Yo. There are several problems with unconditionally calling target compile options. Or target link options. The primary problem is compiler flags are specific to the compiler frontend being used. In order to ensure that our project supports multiple compiler frontends, we must only pass compatible flags to the compiler. We can achieve this by checking the CMake lang compiler frontend variant variable, which tells us the style of the flag supported by the compiler. So that's what they used here to check if it's Visual Studio or else like in Linux. Yeah, compiler front-end variant. Um, Prior to CMake, this thing was only set for compilers with multiple front-end variants in version. After checking this variable alone is sufficient. However, this tutorial targets 3.23 as such. The logic is more complicated than we have time for here. This tutorial step already includes correct logic for checking the compiler variant for these ones. Okay, so um, because we're using earlier version of CMake, we have to do this check, this or this. But for newer CMake versions, we can just check this. Okay. Even if a compiler accepts the flags we pass, the semantics of compiler flags change over time. This is especially true with regards to warnings. Projects should not turn warnings as error flags by default. Yeah, I agree. Because when compiling my project, it had warnings. And just because it had some random warning, it treated it as error. And I didn't know how to stop it from doing that. Warnings flags by default, as this can break their build on otherwise innocuous compiler warnings included in their releases. For errors and warnings, consider placing flags in CMake lang flags for local development builds and during CI runs via preset or deflags. We know exactly which compiler and toolchain are being used in this context, so we can customize the behavior precisely without risking build breakages on our platform. Even if a compiler accepts the flags we pass, this is especially true with regards to warnings. Projects should not turn warnings as error. Okay, add appropriate warning flags to the tutorial executable for Visual Studio Code and GNU style compiler frontends. Okay. Oh, target compile options. And what we used before target compile features and definitions. And here, what they told me to do, my first idea was to, the to do. Here, the to do, this one. They told me to set these ones, and my instinct was to use option or set. But here, they actually give this new function, target compile options, like this one. Target compile options. And here it's on to real executable target. Private. So like this. And here wall. This W is maybe for the warnings, and here for the warnings as well. Uh, 9 and 10 to add the warning flags to tutorial. Since we have already configured, we can build it using the command. There's a simple warning in the build. You can go ahead and fix it. Yeah, I did this and I did this. What's the warning? In the main function in tutorial, unused variable. Yeah, this variable is unused and we should remove it. But here it's a warning and, oh, come on. Wait. Why is there no warning now? CMake preset tutorial clean. Fresh build. It builds. Did it magically disappear? Unused. Yeah, here is it. Unused. Okay, now it issued the warning. What about now? Now it doesn't have the warning. Oh, yeah. When I make a change and compile it, the first time it does it, but when I compile again, it doesn't give it. Interesting. Okay, so this is the error. Now, if we remove those flags, this one can leave it. This is for other machines. And here, look at how that we didn't get the warning and everything was built. But if we get it back, it gives us the warning. It gives us the warning, but still it doesn't treat it as an error. Okay. We can go and just remove it, build, and now no warning. Add appropriate warning flags to the tutorial executable. Okay, we did it, we ran it, we did this. Now, include and link directories. This is the third exercise. Note, this exercise requires building an archive using a compiler directly on the command line. It is not used in later steps. Include it only to demonstrate a use case for target include directories and target link directories. If you cannot complete this exercise for whatever reason, feel free to treat it as information only or skip it. Okay. It is generally unnecessary to directly describe, include, and link directories, as these requirements are inherited when linking together targets generated with CMake or from external dependencies imported into CMake with commands we will cover in later steps. If we happen to have some libraries or header files which are not described by CMake target, which we need to bring into the build, perhaps precompiled binaries provided by a vendor we can incorporate with the target link directories and target include directories command. Link directory and include directory. These commands use properties which map to the L and I compiler flags or whatever flags the compiler uses for link and include directories. Of course, passing a link directory doesn't tell the compiler to link anything into the build. For that, we need target link libraries. The target link libraries is given an argument which does not map to a target name. It will add the string directly to the link lines as a library to be linked into the build, prepending any appropriate flags such as L. Describe a precompiled vendored static library and its headers inside the project using target link directories, target include directories. You will need to build a vendor library into a static archive to complete this exercise. Navigate to the step 4 vendor lib directory and build the code as appropriate for your platform. In Unix-like operating systems, the appropriate commands are usually then complete to do 11 through 14. Vendor lib is an interface library, meaning it has no build requirements because it has already been built. All of its properties should also Be interface properties. We'll discuss interface libraries in greater depth during the next step. Okay, they want me to do this. Just to execute those two commands. So we need to go there. cd step 4 ls and go inside vendor ls, inside lib ls, and this probably compiles it. Yeah, it compiled the CPP. And now we archive it. To a library. Lib vendor a vendor and here it is, lib vendor a. Now we can actually complete this exercise. Here we need target include directories, the include one, and then we need target link directories. Target link directories, and then add the vendor archive, vendor lib. So maybe target link libraries. Vendor lib and vendor inside of lib vendor a should be this, and in here we add subdirectory. So CMake preset tutorial include directories with invalid arguments. Oh, link library need it needs a flag. It needs a flag. So here we need like what interface? And here what a string? Okay, the third problem is fixed. We need the first two. Target include directories called with invalid arguments. So this is the target, and here the directories. Oh, we need the interface. What will happen if here is private? Yeah, it has to be interface. May only set interface properties on interface targets. So because the target is interface, everything else has to be interface. And we build it. Okay, so through 14. This is 13. We need to add it here. Add vendor lib to tutorial. Target link brace tutorial. Will it work? Private vendor lib. Cannot find. Okay. Cannot find this file. No such file or directory. Okay, I'm just inputting the path wrong. Lib. Oh, maybe it's going through from tutorial. Okay, let's see the solution. Yeah, we did this. Target include directories, target link directories. Target link libraries. Vendor. Oh, just the folder. Vendor. So here we have a library. We have target compile definitions. We have a compile definition, but we don't use it. Maybe it's for different exercise. We have include directories, link directories. So the include in lib folder, we have them. Add the vendor archive to vendor lib. And here, tutorial. Okay, they just put it in one place. Inside of the tutorial, they just put it here. Yeah, everything builds as before. Yeah, okay, so with this exercise, I still don't understand target link library. Target link directories. Yeah, I still don't understand target link directories. And this target link libraries part, vendor, because we don't have any target vendor. We don't have a target vendor. We have a library target vendor lib. We have executable target tutorial, and we have library target math functions. And that's how we've managed to use like target link libraries by using those targets. And here we have target link libraries, vendor lib. Okay, this is our target interface. But this vendor, where is it coming from? That's the confusing part, but the interesting part about this tutorial was that there are recommendations like priorities, like first to look through this, then through this, then through this. And I'm surprised that these are like esoteric food guns, like to try to first try it with other ways before using these. Surprised by that. We saw how to set in another way the C++ version instead of those flags. That was interesting. Compile definitions were interesting because we set from CMake definitions that we can later use inside of the code. That was interesting. And what else was interesting? Exercise 2. These compile options are new. Like, what's the difference by just using option and target link options? Target link options. Like, those are compiler specific. Like, I'm not that, don't know much about compilers, so compile options. Also, the options we used were for CMake. And here, this one is for the compiler specifically. Yeah, that makes sense. And that's why we had to check, like, which compiler are we currently, like, is in use. Yeah, that makes sense. So these ones we just pass along to the compiler. What else was interesting in this tutorial? Here it was interesting how we compiled and built the library outside of CMake. And here we are just using it. This will be useful because when I'm making the engine, some libraries, they are pre-built and you just download them. But if I just have the library, why do I need the source code as well? Because I just compiled like we just compiled here this. We just compiled this. Why would I need? Oh, this is for me. This header is for me. I get it. This header is so we can later use the actual library. We compiled it, this thing, and we created the library outside of it. Yeah, but why do we need? Yeah, and I get the include directories. I get that. But I don't get these link directories. Like, why would we need this part when we already just have the library itself? Yeah, that's the confusing part. Build it and run. Yeah, okay. That was this step. Yeah, so thank you for watching. The next stream will be step 5 of all the 12 steps in total. Okay, thank you for watching.